This video will cover section 5.1 class for the class Math 1324, and it will cover examples 7, 8, and hopefully 9. So on this problem, it talks about selling a note, and it's like if someone owes you money and you cannot wait for that person to pay you the money, so then you could sell that that loan that you're holding on someone. You could sell it to a bank, and the bank will pay for it, and then they will try to get the rest of the money from the person who originally borrowed the money. So in this case, we have Larry Parks, and he owes $6,500 to Virginia. The loan is payable in 1 year at 6% interest. However, Virginia needs cash now to pay medical bills. And so she needs that 4 months before the loan is due. So she cannot wait a full year. She needs that 4 months before it's due. So Virginia decides to sell the note or the loan to the bank. If the bank wants a return, because of course the bank always wants to make more money, on 9% of its investment, how much should it pay Virginia for the note right now? So for this problem, we have to calculate two things. And so first, we need to find the maturity value of the loan. So what I mean is, how much will the loan be if we go with the first option? That will include the present value to be the amount of the loan. And then the time, if that was a full year, the maturity of the loan, it will be 1 year. And the rate is 0.06. So if we use our formula to calculate future value, the one that says present value, parentheses 1 plus RT, and we substitute all of our quantities that are available, it will be 6,500, parentheses 1 plus 0.06 times 1. Of course, the 1 is not really needed there. And that will equal to $6,890. So that will be the value of the loan. So when in 4 months, the bank will receive that. So the bank has 4 months only, because remember, the loan was a year loan, 1 year long, and then the money was needed 4 months before. So the bank has 4 months to make that a 9% return. So with this type of future value, we are looking for the present value. So this is the second part of the problem. And we have now for R 0.09. And for our time, we have, the bank only has 4 months. So 4 over 12, or we may divide by 4, so we could use 1/3 as well. So the formula we want now is present value equals future value divided by 1 plus RT. Now here we are talking about two different present values. The first present value was just how much the loan was, how much money was borrowed. The second present value, the one that we're looking for, is the one that the bank has to pay Virginia for that loan at the time that she sells the loan to them, the 4 months before the year. So in this case, I'm going to substitute the future value, 6,800, divided by 1 plus 0.06 times 1/3. And remember here you will need extra parentheses for your denominator. And so this present value is going to equal $6,689.32. So what this means is that the bank pays Virginia this amount at the time that Virginia needs the money, because she originally let Larry borrow $6,500. So she still made a little bit of an investment, a little profit. She made like $189 of profit because the loan didn't go to full term. It was only 6 months. Now the bank paid that much for it, put it in an investment with and actually I made a huge mistake here. This should be 0.09 for the bank. With the higher interest rate, so this should be 0.09 with the highest interest rate, and that's how they were able to make the 6,600 turn him into 6,800. Or in fact, it should have been another mistake. I'm sorry. This number from here, 6890. Okay, so if you notice, they made a little more. No, they actually made the exact amount of what they were supposed to make for a full year term. Okay, so let's move on to example 8. And here we have an investor who bought a 6-month $10,000 U.S. Treasury bill. These are also known as T-bills. And this type of loans, they do have a discount rate. And that discount rate is here. So what is the amount of the discount? What is the price of the T-bill? T-bill is the same name for the Treasury bill. So what we're going to do here is we're going to use the formula for discount. And that is going to equal to the same formula for interest that we looked at the very beginning of the section. Present value times the rate times the time. And so if we substitute those quantities that we know, the present value is 10,000. The rate is going to be 0.0039, because if you notice here, it already has a decimal point there. This is not even 1%, it's below that. We still need to divide by 100. And then for the time, we have 6 months, so that would be 6/12, or we may say 0.5. So I'm going to use 0.5 in this case. And so the discount, or the interest that could have been made, that will become the discount. So 1950. So the price of the T-bill now is going to be the face value or the present value minus the discount, or that interest that we found using that formula. Remember, we said discount is the same. So what we get from here, it will be the 10,000, the face value, present value, minus what we found on the previous step. And so with that, we will get 9,980 with 50 cents T-bill. So what it means is that what you will pay for a bond like that, it will not be 10,000. It would actually be 9,980. Okay, so now last problem of this section, which is actually a continuation of example 8. And so it says here, find the actual interest rate paid by the treasury in example 8. And so right here what we're going to do is use the interest formula again. But what we're going to use for present value is going to be the face value after the discount. So the one that we obtain here. This is the new present value or face value. And so that will be 9,980 with 50 cents. For the rate, we will be using, that's actually what we're looking for. Find the actual interest rate. And then for the time, we have 6 months, 6 over 12. So we will be using 0.5 or 1/2, whatever you want. So in this case, if we take this formula, interest, and we solve for the rate, you could see how the present value and the rate are multiplying to the R. So I'm going to have the interest here on the left, and then present value will go across. It will be dividing, so I will put it down here. And also T is multiplying to the R, so it will go across and it will be dividing. So now with this formula here, feel free to use it when you're doing your homework. The rate will equal to the interest I forgot to write down here the interest or the discounted price. So that would be 1950 divided by the present value is 9980.5 times, not the rate, I'm sorry, the time. The rate is what we're solving for. So the time was 0.5 for 6 months. And so if we enter this on the calculator, I would just to make sure put parentheses around the denominator. So that will give me a rate of 0.003976. And of course, depending on how my math lab wants you to round your answer, you will enter so many decimals. But remember, to convert this into a percent, we multiply by 100. So we're going to be moving our decimal place 2 units to the right. And so this will become 0.39076. And that will be the answer for example 9. And this concludes section 5.1.